So, welcome all. Here Dr. Shah. Today I am going to demonstrate about how water behaves and in PV diagram. See, in PV diagram we have three different phases. In liquid on the left side, pink colored, L plus V, liquid plus vapor phases inside the curved vapor curve dome, and the right side yellow color we are having a vapor. Now in the animation, see here, when we are having a very small amount of volume, see, just increase the pressure in increasing something like this, taking a path in this way. Okay, when you are increasing the pressure, see how the pressure is increasing. The red dotted line is moving path like this. Okay, now just play with the molar volume. When you are increasing the volume, see how the volume is changing, taking a path along the blue line. Okay, like this. Now when the temperature is varying, say in the liquid phase, in this pink region, see how it is increasing pressure in vertical way. Okay, so we are having a temperature, small temperature here, then greater temperature here, then bigger, again it is increasing vertical way. Now just enter in the vapor dome. Okay, inside the vapor dome, what you find, it, the vapor is moving something, temperature. Okay, temperature is again varying linearly up and down. Okay, in the same fashion what it was moving in the liquid region. Okay, now again increase the vapor and let's enter in the vapor region. Now again play with the temperature. See here what is happening, temperature is varying in very small amount. Okay, not what was happening in case of the liquid region, what was happening in the pink region. Okay, in the vapor dome you will find the temperature is varying very small. Okay, why it is happening, because the specific heat of the liquid CPE is 4.8 something value compared to vapor 2.8, just half of the liquid. So the quantity of heat observed in the vapor is very small because the molecules are far up in the vapor dome, in the vapor region compared to the liquid region. That's why heating the liquid is increasing the temperature abruptly in the large fashion compared to in the superheated or in the vapor region. Okay, now next, see in the left side A, B, C, D. When we move from A, B, C, D, okay, let's compare. Let's suppose we are having a cylinder. Inside we are having a gas A. State at A state we are having a cylinder. Okay, let's compress this. So let's set the this red dotted line at A. Let's suppose here I have set. Okay, let's suppose here. Okay, at A point we are having a cylinder gas, we are having. Okay, having this state. Now just what you have to do, inside the cylinder you are just start compressing the gas by increasing the pressure. Now you are increasing the pressure, increasing. Now from A it is moving to B. Okay, now it is moving to B. Okay, earlier it was at A point. Okay, here at A point, now it is increasing and reached up to B point. Okay, now after B, with no change in pressure and temperature, the phase gas changes. So you will find a very fast movement of the red dot. Okay, and reaching up to the saturated line here. Now currently it is at saturated vapor line. Okay, now it is, see, with no change in vapor and temperature. Okay, no change in temperature. See, the pressure currently is 2.257 and temperature is 298. Say increase the pressure with no changes. So this is what B2SC when we are moving. So this is what, this is our latent heat of condensation. Okay, when it will move from left to right, it means when we are moving from C to B here, then we will have to give the latent heat of vaporization. When we are moving from B to C, then latent heat of condensation we have to remove the heat, so then we will move at C. Now currently the position of C dot is at C. Okay, means the liquid has completely liquefied. Now again increase the pressure. What will happen now? What almost vertically or slope gets, this change in the pressure is happening at very rapid rate. Why? Because compressing the liquid is very tough compared to what compressing the vapor here. That's why the slope here, the yellow region or in the vapor region, is very small compared to the slope what we get in the liquid region. Means here slope is very large, and here the slope is very small. Okay, because compressing the liquid in the liquid region is very tough compared to the compressing the vapor.